in previous problem, if 10 to the power 10 electrons is added, then what will be the its new mass? And the m dash equal to m plus delta m10 plus 0.91, 10.91 kg. That is, if electron is added, mass will increase. If electron will be removed, mass will decrease. Next property is charge is conserved. In a system, total charge remains constant with time. However, individual charge may change. That is, charge can neither be created nor destroyed. It means that if we take a system, then total charge will be conserved, but the charge on a single body or on different body may change. For example, here it is shown a nucleus of charge Q dash, where gamma ray stacks in the nucleus, and positron and electron is created. Positron is a particle with same mass of electron but of opposite charge. With opposite charge, that is, positron is positive and electron is negative, but charge value is same and mass is also same. So before interaction, initially Q charge on the body was total charge on the body 0 plus Q dash equal to gamma ray has 0 charge, and already the nucleus has charge, so Q dash plus equal to Q dash. And finally again, after interaction, what happens? Positron and electrons are generated, so final charge will be Q. Again Q will be, because this has charge, so plus E plus minus E plus Q dash, total charge, so 0 plus Q dash equal Q dash. So in this system, charge remains conserved. Again, if we see in this example, this is a uranium nucleus, and after fission it changes into thorium and helium. This shows the number of protons or number of electrons in thorium. So initial charge was 92E here, 92 electronic charge, and final charge 90 E plus 20. Nucleus has only positive charge because we are considering only nucleus, not uranium atom, uranium nucleus. So nucleus is positively charged. So after that, it transformed into thorium and alpha particle. Initial charge 92E and final charge 90E plus 20. Again charge is conserved. In this example, this is called annihilation process. That is, electron and positron annihilate to generate gamma photon, or here it is H nu of energy, which represents energy. This is photon. So initially Q plus E plus minus E equal to 0, and finally again 0 because photon have no charge. This is called annihilation. Next charge is invariant. It means that charge is independent of frame of reference. That is, charge on a body does not change whatever be its speed, but charge density or mass of a body depends upon the speed of the body. On its speed and increases with increase in speed. That is, charge density on a body or mass will increase if its speed will increase, but charge itself remains unchanged. Sixth property, charge in rest produces electric field. Charge in uniform motion produces electric and magnetic field both, and charge in non-uniform motion radiates energy. These are the property of charge. So here see a charge body is in rest, V equal to 0, that is, velocity is 0, so only electric field is generated about all around its body. And if it is in motion and with constant velocity, then electric and magnetic field will be generated. but no radiation will be generated. Again, if charged body is in accelerated motion, that is V is not constant, and EB and radiate energy, electric field and magnetic field will be generated, and also it will radiate energy. Now 7. Similar charge repel each other while dissimilar attracts. It means that same type of charge will repel each other, apply force to each other away from body, away from it. That is, this is a body and this is another body, both have positive charge. So this body will repel, this we apply a force in away from this body in this direction, and this also apply a force in this direction. Force of repulsive, we may say that repulsion force acts in same nature of charge. This is also negatively, both body is negatively charged, so it will repel each other. So it will, this body will repel in this direction and this body repel this body in this direction. Now if dissimilar charge, that is like this and this, so both body will attract each other. This body will push this body towards itself, and this body in toward itself, and this will be the force of attraction. For example, here it is shown separately. This is positive charge and this is negative charge. Both body are attracted to each other. Here this is positive charge, this is positively charged, this is negatively charged, and both, when we release it, both body will be attracted. That is, this body will push towards itself, and this body will push this body in this direction. Now conductors and insulators. So we have gone from different property of charge. Main property is that charge is invariant and charge remains conserved, and similar charge, there is attraction force between the similar charge and repulsion force between similar charge. So these are main property. Now let's discuss one by one conductors and insulators. Conductors and insulators. Conductors, in these material, charge are free to move from one place to another within the material. For example, metals, human body, earth, it are considered as conductor. And insulators, in these materials, charge are tightly bound to their respective atoms. So for example, glass, hard rubbers, plastic, etc. are insulators. In this material, charge is bound and they are not free to move from one place to another place in the body. Next is in metal, free charges are free electrons known as conduction electrons, and in metal, charge is due to the free electrons, and it flows from body from one point to another point, and these are called conduction electrons. The free electrons in metals are known as conduction electrons. Now charging of a body. There are different methods for charging of a body. We can charge by rubbing. First one is charge by rubbing, frictional electricity. This is called frictional electricity. For example, here it is a silk cloth and is a glass rod rubbed with each other, and after it the glass rod become positively charged and silk cloth become negatively charged. That is, electron transferred from glass to the silk cloth. So silk cloth become negatively charged, and this has become positively charged. And this is due to transfer of electrons, because electron is transferring from one body to another body. Here again another body is shown. This is wood and ebonite rod. When wood is rubbed with ebonite rod, and ebonite rod become negatively charged and wool become positively charged. This was seen by experiment. Next, charging by conduction or contact. Charging by conduction or contact. In this case, we take a body on an insulated stand, and a charged body is bring near the metal sphere or metal body, and due to induction, if we touch this is by charging by contact or conduction. It is called charging by conduction. We bring say ebonite rod, that is negatively any another body can be also bring. This is negatively charged rod, and it is bring to the metal sphere and touch to it. Then electron will transfer from this rod to the this body, and this body will be negatively charged. And like this, here it has become negatively charged. It is placed on the insulated stand, because if we not place it on, then charge will flow to the earth. Again here negatively positively charged rod has brought, and it is touched to the metal sphere, and the metal sphere is on insulated stand, and again some charge will transfer to the this body, and this body will be positively charged as shown in the figure. In the process, electron transfer from rod to metal sphere in first case, while electron transfers from metal sphere to rod in second case. Here it is clear that in this case, because only electron is transferred from metal body, so here if this is negatively charged, then it has excess electron, and some electron will transfer to this body on isolated. Initially it is isolated, but after gaining some electrons, it will be negatively charged. Again here in this case, because this is a positively charged body, and this because only electron can transfer, so electron from this attracted by this body, and some electron gets to this body, and so due to loss of electron, this body becomes positively charged, because number of protons increases in this body. And this is it is said here in the process, electron transfer from rod to metal sphere in first case, and while electron transfer from metal sphere to rod in second case. Now next is the charging by induction. It is also a method of charging a body, and in this case the charge is called induced charge. Here what this process is done in 3 steps. First we bring a charged rod and a sphere, uncharged sphere is placed on the insulated stand, and then bring a charged sphere. Now due to induction, because it has electron, so what will have the body this electron will repel the electron in this body, and this electron will come in this side, and so this side will be positively charged. And here we are not touching the body. Body is very near, rod is very near to the metal sphere. Here it is shown, and this is inducing body, because it induces charge in this body, so it is called inducing body. So this part become positively charged, and this part become negatively charged. Now we this side is grounded, that is, it is connected with a wire to the ground, and so total this negative charge will flow to the ground, and then we remove the grounding, and so whole body becomes this positive charge is spread on the body, and there is a net charge on the sphere. This stand is also insulated, and so body will remains so body becomes positively charged. So in 3 steps we can make a body charged by induction, and this is called inducing body, and this is called induced body. Now regarding electrostatic induction, we have to keep some point in our mind that A inducing body neither gains or nor losses charge. Inducing body means here rod is inducing body, because we have bring this rod to induce charge in this body, because this body is not touch here, so no transfer of electrons from this body takes place, only redistribution of charge in this body is takes place. Negative charge place comes in this side, and positively charge remains in this side. So inducing body neither gains nor losses charge. B. The nature of induced charge is always opposite to that of inducing charge. C. Induced charge can be lesser or equal to inducing charge, but never greater, and its magnitude value is given by Q dash, that is, this is induced charge, equal to minus of Q into 1 minus 1 by K, where Q is the inducing charge, that is charge on the rod, and Q dash is induced charge, in this case charge on the metal sphere, and K is dielectric constant of uncharged body, dielectric constant of uncharged body in a metal sphere. This will be discussed next further, what is dielectric constant. Here it is not necessary. So D, for now for metal, K is infinity, that is dielectric constant of metal is infinity, hence Q dash equals to minus Q into 1 minus 1 by infinity equals to minus Q. Thus if Q is positive, that is Q is positive, Q dash is negative, it means if inducing charge is positive, then induced charge will be negative in case of metal, and if Q is negative, then induced charge will be positive and of same magnitude. See, induction takes place only in bodies and not in particles. This is have to keep in mind that induction takes place only in body and not in particles. It means that you cannot induce charge on electron or proton. It means that no charge given to the for metal, Q inducing charge, Q dash induced charge, K dielectric constant of uncharged body. Here D equal for metal, K is equal to infinity, hence Q dash equal to minus of Q into 1 minus 1 by infinity equal to minus Q. Thus if Q equals to positive, Q dash equal to negative, and Q is equal to negative, Q dash equal to positive. That is, if inducing charge is positive, then induced charge will be negative. If inducing charge is negative, induced charge will be positive. See, induction takes place only in bodies and not in particles. It means that you cannot induce charge on the electron or proton or any particle, elementary particle. No charge given to the body, charge given to the conductor resides on outer surface of the conductor. It should keep in your mind that charge given to the conductor resides. For conductor, it is conductor. This is true for only conductor. Charge given to the conductor resides on outer surface of the conductor.